Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students. Right. In a last session, we discussed about what is the string efficiency, what is the importance of string efficiency, and what is the formula for string efficiency, and what are the methods to improve the string efficiency that we discussed. Right. So what are the methods that we can increase the string efficiency? The first one is longer cross arm. I just want to brief rewind, right? Longer cross arm. So if you are taking the longer cross arm means your shunt capacitance is going to be eliminated. So if the shunt capacitance reduces means definitely we are maintaining the equal voltages across each and every disc. Right. So if you are providing equal voltage means you are improving your string efficiency. Right. And the second one is by capacitance grading. Right. So we have a different capacitance splits that are going to be inserted in a string. So that means whatever the capacitance nearer the conductor which is having a low capacitance, because the stress on that capacitance is very high. So in order to compensate this thing, we need to take the lower capacitance. From the bottom to top, your capacitance is going to be increases. Because the voltage level is going to be reduces. Your capacitance is inversely proportional to the voltage. So it's very difficult to maintain each and every different types of discs that can be inserted in a string type insulators. Why? Because it's very difficult to estimate. The cost based issue is one of the factor, and it's very difficult to estimate each disc. Actually, in a suspension type insulator, each disc can be represented by 11 kV. So how many discs that are inserted means how many discs are inserted means that number of that much amount of current that can be carried. So if you are placing different graded capacitance in a suspension type insulator, it's very difficult to estimate how much current that can conduct or carry, how much voltage that can carry. It's very difficult and cost based issue. Alright. And after that, third important is a cord rings. Very important. Nowadays in a transmission system, you will see these type of guard rings that are placed to maintain the voltage across each and every disc is a uniform. How means one metallic sheath is there, one metallic conductor is there, it can be placed at the bottom of the metallic sheath to cross arm or insulator, whatever it may be. So the metallic sheath and a metal conductor, there will be a capacitance will be exist. These capacitance can nullify the shunt capacitance between the pole and the metal. Alright. So if that the shunt capacitance is going to be eliminated. If the shunt capacitance eliminated means whatever the effect due to the shunt capacitance is going to be eliminated. If there is no shunt capacitance means whatever the current that can be flow through the string is a constant. So if the current throughout the string is a constant means the voltage across each and every disc is a constant. So that means you are providing a uniform voltage across every disc. So that means you are providing string efficiency is going to be increases, right? You are providing the voltages are equal. That means you are improving a string efficiency. So these are the methods to improve the string efficiency that we discussed in a last session. And one important notes for a gate oriented point of view. So what that notes that we discussed, the first note is whatever the conductor, the disc which is nearer to the conductor which is having a maximum stress and goes on, the maximum stress is going to be increases. That means the chances of flashover, a puncture that occur nearer to the conductor is very high. If it is got damaged, that means the total conductor will get, total string will get destroyed. That is one. And the second one is, if a K value increases, what about the efficiency? These are the questions in a gate that recently you are getting these type of questions, right? That's why I'm explaining, right? If K increases, what about the C1? K is nothing but C1 by C now. So C1 is increases, K increases. C1 is nothing but shunt capacitance. Alright, if a shunt capacitance increases, what about the uniform voltage? Definitely we are not maintaining the uniform voltage across each and every disc. So what about that string efficiency? Efficiency is going to be reduces. Right? If K is reduces, your efficiency is going to be increases. This is one of the most important question. After the third thing is, whatever the voltage that appears across the string, total voltage, V is equal to V1 plus V2 plus V3. This we can call it as a phase voltage. Always you can take it as a phase voltage. Right? You know the formula, line voltage is equal to √3 into phase voltage. Right? So you can assume that this phase voltage is the voltage across total string. Right? So these are the important notes you will get in your competitive exams, right? In a string efficiency manner. And what are the formulas to solve the problem means? I think already I discussed about the formulas. The first formula is K is equal to C1 by C, shunt capacitance by self capacitance. After that, what is the formula? If V is equal to V1 plus V2 plus V3. So this is a phase voltage. What is a V? V2 is equal to V1 into 1 plus K. This is the third formula. We already derived all these formulas, right? What is V3? V1 into 1 plus 3K plus K square. Or else you can write it out. V2 plus V1 plus V2 into K. In another way you can write it out. And the fourth formula is, what is V1? V1 is equal to V by 1 plus K, 3 plus K. Right? And what about the string efficiency? Total voltage by number of disk into whatever the voltage across the conductor's disk. So this is the string efficiency. So these are the formulas. It will be useful while solving the problems, right? Now we'll solve some problems on string efficiency. With that we will complete this unit. Alright, shall we start the problems? Right, if you have any doubts regarding sag, tension, insulators, right, why we should maintain a string efficiency, methods to improve the string efficiency, each and every insulators, right, if you have any doubts, feel free to ask me. I'll definitely explain and definitely conclude your doubt. Right? Shall we start the problems? 2 or 3 problems is there, so with that we finish this concept, right? First example. In a 33 kV overhead line, there are 3 units in the string insulator. There are 3 units in string insulator. If the capacitance between each insulator pin and earth is the capacitance between each pin and earth is 11% of self capacitance. 11% of self capacitance, right? Find the voltage distribution along the string and find string efficiency and find sing efficiency. Right? I'll read the question one more time. In a 33 kV overhead line, there are 3 units in a string insulators, right? There are 3 units are going to be suspended, right? String insulator. If the capacitance between each pin and earth, that means a shunt capacitance, is 11% of self capacitance. Find the voltage across voltage across the total string and find the string efficiency, right? It's a simple question. So first you have to analyze. This is a cross arm, this is a pole, and this is a self capacitance, another self capacitance, and where the conductor is going to be twisted here. This is the shunt capacitance, this is the shunt capacitance, and this is the shunt capacitance. Given between each and every, so this is a self capacitance and this is the shunt capacitance, right? So you have to find out V1, V2, V3, right, and find out the total string efficiency of the system. So given the shunt capacitance is 11% of self capacitance. So what is the formula for K? K is equal to shunt capacitance by self capacitance. So that means, what about the shunt capacitance? So given 11%, that is nothing but 0.11. So you'll get the K value 0.11. That means shunt capacitance is equal to K times the self capacitance. You applied, it's called 11%. That means 11 by 100. So we can call it as a K value 0.111. You know the K value. Now what is the formula for V2? V2 is equal to V1 into 1 plus K. You know the formulas. So substitute it. So what is a V2? V2 into 1 plus 0.11. So that means 1.11 K. So you got V2. So what is the formula for V3? V3 is equal to V1 into 1 plus 3K plus K square. Right? If you substitute K value 0.011 here, you will get the equation 1.342 V1. Right? So V1. Right? And what is a V value given? So what is a V value in a 33 kV overhead line? V is nothing but the total string voltage, right? But given is a line voltage. But what about the string voltage? Total string is nothing but V is equal to V1 plus V2 plus V3 now. So there is a line voltage or a phase voltage. This is a phase voltage. But given 33 kV overhead line voltage, so that means the phase voltage is equal to line voltage by root 3. So that is nothing but 33 by root 3. So what is the voltage? 33 kV by root 3. That is nothing but 19.05 volts. So you know the V value. So from that, what is the value of V1? V by 1 plus K, 3 plus K. Substitute. You know the V value. 19.05 by 1 plus 0.11, 3 plus 0.11. Right? Substitute. You will get the value of V1. So what is the V1 value? You will get 5.52 kV. You know the V1 value. So V2 is equal to V1 into 1.11 K. You know the V1, 5.52. Substitute, you will get V1, V2. So what is the V2 value? So we'll get the value of V1. So what is the value of V1? V1 is equal to 5.52 kV. So you know that V2 is equal to 1.11 V1. Substitute it 1.11 into 5.52 kV. So what is the value of V2? From that you will get 6.13 kV. Right? So what is the value of V3? V3 is equal to 1.342 V1. So what is the 1.342? Already you derived, right? 1.342 V1. From that you are substitute. You know the V1. Then substitute. 342 into V1. So 5.52 kV. So what is the value of V3? You will get 7.4 kV. See, from here you will understand. Right? Right? What is the value of V1? So you will get the value of V1 is 5.52. So what is the value of V1? 5.52. So what is the value of V2? What is the value of V2? 6.13. 6.13. What is the value of V3? 7.4. So that means whatever the disc which is nearer to the conductor, which is having a maximum stress, right, which is having a maximum voltage. So definitely there will be a first chance to occur a flash or a puncture on this disc. If this disc fails, definitely the total string will get damaged. So that's why we need to maintain in the voltage across each and every disc is a constant value. So from this you will see the voltages are going to be non-uniform, right? The voltage nearer the conductor disc is very high. So that is the importance of the string efficiency. Nothing added, right? And what about the string efficiency? So you know the value of already, and they asked the total voltages. What are the voltages? You find out the V1 value, you find out the V2 value, you find out the V3 value. Alright. So total string efficiency. What is the total voltage? V by how many discs? There are 3 discs. What is the voltage across near the conductor's disc? The total voltage. What is the V value? Into 100 because percentage na. So what is the V value? 19.05 by 3 into V3, 7.4 kV. This is also kV. Then you will get into 100. You will get 85.8%. The string efficiency is getting 80.8%. This is the questions they asked. They find each and every voltages across each and every disc and to find the total efficiency of the string. Right. So in this way they'll ask the questions, right? Nothing is there. They'll give the K value and find out the voltage across each and every disc. You know the formulas. V1 is equal to V2 is equal to V1 into 1 plus K, V3 is equal to V1 into 1 plus 3K plus K square, and V1 is equal to V by 1 plus K by 3 plus K. Just substitute, you'll find out the V1, then substitute, you'll get the V2, V3 values. You know the value of V1, V2, V3, 1 point is over. After that, they want to find the efficiency. So, string efficiency, what is the formula for string efficiency? V by number of disc into the voltage nearer the conductor into 100. That means total voltage substitute cheste you will get the result as 85.8% of a string efficiency that you will get. So this is one model. This is not that much of a strengthful question, right? So now we'll discuss another question, somewhat a difficult model that we discussed here, right? Example 2. Each line of three-phase system is suspended by a 3-disc string insulators. Right, suspended by string insulator. If the voltage across the line unit is, if the voltage across the line unit is 17.5 kV, calculate the line to neutral voltage. So that means the string voltage. Assume that shunt capacitance is 1 by 8 of self capacitance, and calculate string efficiency. Right. So first read the question. Each line of three-phase system is suspended by 3-disc string insulator. Okay. Try to draw the figure itself. Right. How many discs? 3 discs. So this is conductor, right? So this is a self capacitance. So this is KC, this is KC, this is KC. This is a self capacitance, and this is a shunt capacitance, right? Nothing is there. 3 disc. Right, the voltage across the line unit. So which one is the line unit? So this is a line now. So which one is a line unit? So this one is a line unit. So the voltage is given. So what is 7.5 kV? So this one is given. Calculate the line to neutral voltage. So calculate the string voltage. So calculated the total voltage. They'll ask what is V value. Given K is equal to 1 by 8. You know the K value. They want to calculate the V value and find out the efficiency. Right? So given V3, given V3 is equal to 17.5 kV. Right? Right? You know the formulas. What is V2? V2 is equal to V1 into 1 plus K. Na? Right? Substitute it. So 1 by 8 is nothing but 0.125. Na? Right? So V1 into 1 plus 0.125. 1.125 V1. Right? You got V2 value. So what is V3 value? V3 is equal to V1 into 1 plus 3K plus K square. Right? You know the K value, 0.125. Substitute it. You will get the value of 1.39 V1. Right? Just K value substitute. V1 into 1 plus 3 into 0.125 into 0.125 square. Right? If you calculate this one, you will get the value of V3. Now you know the value of V3. Now the person is given. The value of V3 is the voltage nearer to the line, which is V3. So V3 is given as 17.5. Then substitute. 17.5 kV is equal to 1.39 V1. Right. So from that, what is a V1? 17.5 by 1.39. So from that, you will get the 12.59 kV. Right. You got the value of V1. Right. You know the value of V1. So V1 is over. V3 is given. So the V1 is 12.59 kV. Now you want to find out the value of V2. So what is the value of V2? Right, so V2 is equal to 1.125 V1. Substitute it is. So V2 is equal to 1.125 V1. So that means 1.125 V1. What is the value of V1? 12.59 kV. Right, then you will get the value of V2, 14.16 kV. You also got V2. You also got V2. You got V2 also. So what is the value of V2? 14.16 kV. You will cross check whether the voltage keep on decrease. Voltage from top disk to bottom disk, your voltage stress levels should be increases. That means the conductor near the disk, right? The disk which is nearer to the conductor, which is having a maximum voltage, and keep on decreasing through the cross arm, right? So you got the V2 value, you know the V1 value, you know the V3 value. Then find out the total disk, total line current. Nothing, simple problem. First you have to understand what they given and what you are going to calculate. Then it will be easy for you, right? You know the value of V1. So what is the V1? 12.59 kV. So you know the value of V2, 14.16 kV, V3 given 17.5 kV. So what is the total voltage? V is equal to V1 plus V2 plus V3. Then substitute, you will get the 44.25 kV. So this is a phase voltage, right? Then what about the string efficiency? Total voltage 44.25 by how many discs? 3. So what is the voltage nearer to the conductor? 17.5 kV. Into 100. If you substitute it, you will get the 84.28%. So these two things they asked. So what is the voltage? You have to find V1 value, V2 value, V3 value, then find out the total voltage across the string, then find out the string efficiency. Right? I hope it's clear in this type of a model. Right? Right? Nothing is there. We'll go for another model. Right? I don't want to write the total because the two models are enough. I just want to write out what are the things they given and what they want to find out, right? So given, okay, I'll write out because this is very important questions that I need to there. The 3 busbar conductors in outdoor substation are suspended by the overhead transmission line is suspended by string insulators. String insulator. The voltage across the lowest insulator is 13.1 kV. That next insulator is 11 kV. Right? Then find the bus bar voltage. Right, the bus bar voltage. See what they given. The overhead transmission line is suspended by string insulator, so which is having how many discs? 3 discs. That need first try to draw the figure first. Right. So this is the conductor. The lowest value of insulator's voltage is given 13.1 kV. Right, across this this insulator also given. Then find out this voltage, bus bar voltage, not the string voltage. They wants to calculate the bus bar voltage. Right. That is nothing but this is a phase voltage and this is a line voltage. Right. If you calculate this voltage, then it will be easy for you to calculate this one. Right. So what they given? V3 is given. So V3 is 13.1 kV. V2 is given 11 kV. And what is a V1? You don't know value of V1. If you know the value of V1, you can calculate the total voltage, which is a phase voltage, then find out the line voltage. That is nothing but into root 3. Definitely you will get the line voltage, right? But for this, if you want to know the value of K, you don't know the value of K also, directly substitute, right? So what is the value of V2? V2 is equal to V1 into 1 plus K. Right? You don't know the value of V1, right? You know the value of V3, V2. So from this, what is V1? V1 is equal to V2 by 1 plus K. Alright? And what is the value of V3? V3 is equal to V1 into 1 plus 3K plus K square. You don't know the K value, you don't know the V1 value. So this is not useful formula. So you have to use V1 plus V2 into K. Alright? So then you have to substitute V1 plus, what is the V1 here? V2 by 1 plus K from the above plus V2 into K. Alright? So from that you will get a one quadratic equation, right? So So what is that equation? So 1 plus k LCM, so V3 into 1 plus k ikkadiki vastadi. Then you will get so the formula is V2 here, not V1. V2 plus V1 plus V2 into k, right? Then you will get V2 into 1 plus k plus V2 plus V2 into 1 plus k into k. Nothing is there, simply LCM. Then the figure went into this this side, right? 1 plus k. Then it will be moved to the V3 into 1 plus k. Then one equation you will get. So after that, nothing is there. You don't know the k value. If you know the k value, then directly substitute V1. You will get the result and directly find out the phase voltage. But what should I do? So what is the value of V1? So V1 is equal, V2 is equal to V1 into 1 plus k. You know the formula. From that, V1 is equal to V2 by 1 plus k. Okay, find out. Because you don't know the V2 value, you don't know the V1 value, you don't know the k value. From that, V3 is equal to V1 plus 1 plus, you know the formula. But this formula is not enough. So that's why I'll go for another formula. V2 plus V2, V1 plus V2 into K. So from this, you will substitute the value of V1. From that, all the figures, you'll get the quadratic equation. So what is that equation that you got? If you solve this one, you'll get the equation. So what is that equation? V3 into 1 plus k is equal to V2 into 1 plus 3k plus k square. So in this form you'll get. So you know the value of V2. Right? What is the V2 is given? So V2 is 11 kV, 1 plus 3k plus k square. Right? You know the value of V3. So what is the value of V3 is given? 3.1 into 1 plus k. Then substitute. Solve this thing, you will get the k value. So what is the k value is 0.1. Okay. At last you'll get the k value. So you know the k value, then substitute and find out the V1. So V1 is equal to, what is the formula? V2 by 1 plus k. Right? So V2, what is the value of V2? 11 kV by 1 plus 0.1. So 11 by 1.1. So what is the value? 10 kV. Right? Last you will get all the values. Right? So whatever the format is this, so first you need to find out the k value. So with that you can calculate the value of V1, V2, V3. 10 kV you got. See, 10, 11, 13. The voltage goes on increases, right? From top to bottom. That means the conductor, the disc which is nearer to the conductor, which is having a high potential. Next, what they asked, the total voltage. First you have to find out the string voltage, V equal to V1 plus V2 plus V3. So what is a V1? 10 plus, what is a V2? 11 plus 13.1. That means the total voltage 10, 11, 21, 13. That means 34.1 kV. Right? So this is a phase voltage. What he is asking, bus bar voltage, that is nothing but line voltage, right? So V line or a bus bar. So that is equal to root 3 into V phase. So what is the root 3 into V phase value? Anta 34.1 kV. If you substitute 59 kV. So this is the line voltage, bus bar voltage. That means conductor's voltage, and that means 59 kV. Right? So in this way, if they ask efficiency, that means you have to find out the total voltage 34.1 by 3 into V3 13.1. So with it, you'll find out the efficiency also. In this way, these type of difficult questions also they will ask. First, try to understand the question and what they ask, how to find the k value. If you know the k value, then directly substitute the value of V1, V2, V3 you'll get. Then find out the phase value. If they ask, find out the string efficiency. If they ask, find out the bus bar voltage. So these type of questions you will get in your end exams, right? That's it. That's about this unit, like a sag, tension, insulator, and we did some problems also. I hope it's clear, right? The next session we'll discuss the brief contents that we discussed till now, and unit 2. Right, these are the things that we discussed in our next class. So with that we'll finish all the unit related to sag, tension and insulator, all these things. Thank you for now.